When we look up at the night sky, everything we see, every star, planet, nebula, and galaxy, feels overwhelmingly vast. Yet modern cosmology reveals a surprising truth. Everything visible, everything made of atoms, accounts for only about 5% of the universe. The remaining 95% is completely invisible. It does not emit light, reflect light, or interact with electromagnetic waves in any way. And yet, its presence is undeniable, written into the gravitational structure of the cosmos itself. Without this unseen matter and energy, the universe as we know it could not exist. Dark matter, for instance, acts as a kind of invisible skeletal framework. When scientists observed the rotation of galaxies, they realized something didn't add up. Stars were moving far too quickly to be held in place by the gravity of visible matter alone. Entire galaxies should have been flying apart. Instead, they were perfectly stable. The only explanation is that each galaxy is surrounded by a massive halo of unseen matter, providing the gravitational glue that binds everything together. This invisible substance outweighs normal matter roughly 5 to 1. Perhaps even more fascinating is the fact that dark matter likely passes through us constantly. According to theoretical calculations, trillions of dark matter particles stream through your body every second without leaving the slightest trace. They don't collide with your atoms, they don't generate heat, and they don't alter your cells. In fact, if dark matter did interact strongly, we would have detected it long ago. Our reality is immersed in a sea of particles that ignore us completely, yet they shape the large-scale structure of the universe. Dark energy, on the other hand, is even more mysterious. By studying distant supernovae in 1998, astronomers discovered that the expansion of the universe is accelerating. This was a shocking revelation. The expectation had been the opposite, that gravity would gradually slow the expansion, perhaps even reverse it one day. But the data was clear. Something was pushing space apart faster and faster. Today, we refer to this unknown force as dark energy, and it constitutes nearly 70% of everything that exists. We still have no clear understanding of what it is, why it exists, or how it behaves, yet it determines the ultimate fate of the cosmos. If dark energy maintains its current strength, distant galaxies will eventually recede faster than the speed of light, slipping beyond the observable horizon over unimaginable timescales. The sky will lose its familiar tapestry of stars. Future civilizations, if any survive that long, might see nothing but an empty, starless void, unaware that the universe was once filled with billions of galaxies. Their sky would look profoundly different from ours, not because the stars disappeared, but because the universe expanded until light could no longer reach them. There is an even more dramatic possibility that dark energy is not constant, but increasing over time. If it grows stronger, the universe could undergo what physicists call the Big Rip. In this scenario, the accelerating expansion becomes so extreme that it overpowers every known force. Galaxies are torn apart first, then star systems, then planets, and eventually, even atoms themselves cannot resist the stretching of space. The very fabric of matter would unravel. All of existence would dissolve into a cold, structureless darkness. It is a distant and uncertain possibility, but it reminds us how little we truly understand about the forces shaping our universe. What makes all of this so astonishing is the realization that the matter we interact with every day, atoms, molecules, life itself, is the exception, not the rule. Our entire reality is built from a tiny fraction of the universe's ingredients. This raises profound questions. If most of the cosmos is invisible, what does that say about our place in it? Are we simply living on the surface of a much deeper, hidden reality? And if the universe is dominated by forces we cannot see, how much of it can we ever truly hope to understand? As our instruments grow more sensitive and our theories more refined, we are beginning to uncover hints about this hidden side of the universe. Experiments deep underground are listening for the faintest collisions of dark matter. Space telescopes are mapping how dark energy stretches the cosmic web. Every new piece of data adds to a picture that is both clearer and more unsettling. The more we learn, the more we realize how much remains concealed. Yet there is something deeply human about this quest. For thousands of years, we looked at the night sky and assumed that what we saw was all there is. Now we know that the visible cosmos is just a thin layer, a bright surface above a vast ocean of hidden phenomena. And perhaps, as we learn to see beyond the limits of light, we are also expanding the boundaries of our own understanding. When you look up at the stars tonight, remember, you are not just seeing distant suns. You are looking through a universe dominated by darkness. Dark matter holding galaxies together, dark energy stretching space apart, and an unseen structure that determines everything from the formation of stars to the fate of time itself. The true story of the universe is not the story of what shines, but of what remains hidden, and we are only just beginning to uncover it.